When we talk about large language models in production, there's a lot of excitement around new techniques like RAG, GraphRAG, and MCP. But here's the thing, none of these approaches really matter unless we can measure how well they perform for real users. Well, that's where A/B testing comes in. So I've been playing around with these technologies for the last several weeks, and I built a simple app that really allows you to do A/B testing in context of GraphRAG, MCP, AB, LLMs, and all of these can be done as a web interface, or what I've also done for convenience, created simplified Postman collections for each one of them. All right, so let's take a look at this app and see what we're doing over here. So this is a simple app that I've built. As you can see, there are different tabs here: GraphRAG, MCP, A/B testing. Settings is where you can set up your model keys, etc. But we'll get to that in a second. The different protocols are supported over here: REST API, GraphQL, gRPC, so on and so forth. A wide range of LLMs are supported. Only a handful are listed over here. Of course, through Ollama, you can run any model locally over here. And then over here, these are the tabs here. So now let's go back to settings for a second. So if I click on settings, this is where you can set up your model API keys. This is where you can set up your MCP servers, how they are configured. It shows you the current status, which one is running, not running. So for example, GitHub MCP server is a remote server. Filesystem MCP server is running locally. And this SQLite is running as a Docker server. And you can run the server from here or set up the server from here itself. But we're not going to go there over there. Okay. Then similarly, you have some GitHub and token settings here that you can configure as well. So I'm not going to go over these settings, but let's go to the fun part of it. So let's go to GraphRAG first. Now, what I have is a simple text file which has some graph information. I'm using ArangoDB because that runs much better in the memory, scales a lot better, that kind of stuff. So I'm going to click on this text file. It's going to use this text file, and it's going to build a knowledge graph with it on ArangoDB. I could go to localhost 8529 to see the admin interface and do direct ArangoDB operations as well. But essentially, you can see that 22 entities, 925 relationships are identified. This is a very simple web interface using D3.js. It kind of shows what all is available. Okay. Now, what I can do is to this GraphRAG, using this graph, I can issue the query to the backend. The GPT-5 mini is configured as a default model, so that's what it's going to use, but it's configurable. We'll go through that a little bit later. But I can essentially issue a REST query. So I can make a REST API call. And that will allow me to compare between GraphRAG versus traditional RAG responses. So if I say, what is the relationship between AI and healthcare? Okay. And here we are using GPT-5 mini as the standard model. So now when I click on this button, this is actually going and talking to the backend of GPT-5 mini, grabbing all the information from ArangoDB, and then retrieving the responses back to you. So you can see the GraphRAG response, the traditional RAG response, and you got some analytics as part of it. So this is sort of the A/B testing part of it. You get some real value and input out over here on what you want to get out of it. And of course, these metrics are for this particular data set, this particular configuration. So you got to run it, what works for you, what doesn't work for you, and you can improve these metrics to be more relevant for your use case. Now, this is comparing GraphRAG versus traditional RAG. Using REST API, I can issue it just a straight up GraphQL query. So I can say execute query, and boom, it just goes and issues the GraphQL query to the backend and returns the response back to me. There we go. All right, so we have a return. We got a response back here. This is a traditional GraphQL query, and the response comes back to us. And we have some predefined queries that you can click here, and it'll run those query for you. So you can do that for different protocols. gRPC streaming, which you can use gRPC straight up or gRPC-Web as a different protocol. Or you can do that over WebSocket or server sent events. For each of these, some predefined queries have been given. You can run it, and then it will return the response back to you. And if you think about it, on the top here, there is a button which says add GraphRAG REST to Postman. this will automatically add a Postman connection. But I'm not going to do that yet. What I'm going to do is I'm going to go to protocol comparison. And I'm going to say, this is my query that I want to execute. And what it'll do, let me run the query first. What it's doing at the backend is basically issuing a REST, GraphQL, gRPC, gRPC-Web, WebSocket, and SSE using the same GraphRAG query going to the GPT-5 Mini. And it's going to return the response back to me. So that way you get an idea of what all is happening across different protocols, what the latency is, what the response looks like. It goes a little bit longer, so we'll wait for a few seconds here. Voila, we have a response here now. So you can see REST, GraphQL, all the different protocols are shown over here. You can see the latency. You can see which protocol is used, what the payload size looks like. You can see the response from each one of them. And there's some pretty charts here as well that can allow you to compare. Now, let me click this button here, add comparison collection to Postman. Now, when I click on this, that collection is now added to my Postman desktop, which is running locally on my machine. So let's go there. So here I am. This is my Postman collection now. All my individual tests are available over here as well. But when I look at the protocol comparison test, I can say it's basically going to use the exact same backend endpoints. And I can say send. Now it's running the exact same query using Postman. All right, so we got the response back here. A very similar response. Well, of course, it's got to be because we're running the exact same query here. So the advantage of this is now I can give this collection to somebody. They don't need the elaborate setup and everything, and they can just run this test exactly in their Postman. So they just need to configure the right keys for the backend, like whether you're using OpenAI or if you're using Ollama and Llama 3.2 running locally on your machine, then no keys are required. So you can make those tweaks over here essentially. So that's the fun part. So let's go back to our web interface. So now I'm going to go to the next part here. Let's look at the MCP here. In case of MCP, we have done 3 different MCP integrations here. MCP, first of all, is Model Context Protocol, and it provides a standard set of tools that allows different tools, external tools that can be integrated with an LLM. Okay, so GitHub MCP is a GitHub remote server. So this is a remote server hosted by GitHub, and that's what we're going to use here. And then we're going to talk about other MCP servers as well. So let's take a look at GitHub MCP server first. So what I could do is I could give a simple query here, get user repositories. It's configured for my account. So it's going to go get the numbers. The number here is 123, which doesn't match the number of repositories on the public page because it's how many are forked, etc., etc. So all of that dynamics is there. But essentially what I can do is now I can click on add to Postman here, and this collection will get added to Postman. So let's try that now. So if I say add to Postman here, GitHub MCP collection is now successfully created in Postman desktop. And now I'm in Postman desktop here. So if I come here and I can issue the same request here. So let's initialize sort of the MCP session here, which gets us the right session ID. But then when I say get user repositories, voila, we get the same number here. So it gives us the thing over here. I can also look at the console over here, and it provides a bit more readable information. At least the top 5 repos are shown over here. Okay, so we're going to get rid of console here so that we get a better view over here. Then we can start getting a lot more detailed information about the repository, etc. But the whole point here is not about what information are we getting, but it's the integration, the way integration is being done. Back to our web interface, I have a local file system MCP server running over here, which is basically borrowed from the MCP GitHub repo, and I have that running over here. Again, I can say, show me the list of allowed directories where operations can be done. I can see the list, the directory contents, all sorts of stuff can be shown. I can read, write, test file, and exact same information can be then added to a Postman collection. So if I say add to Postman, voila, it's added to Postman here. And now I'm back in Postman here. So it says official file system MCP server. I can say list allowed directories, and it shows me the list of allowed directories. I can create a file, read a file. So let's say if I want to write a test file here. So issue the command, it goes and writes it to private temp. And then when I read the test file here, it reads the exact same test file and says this is the time zone, date, etc. in which it's written. So all of that is possible. Back in the web interface, my final MCP server here is the SQLite MCP server. Now this one is running in a different mode. This one is encapsulated as a Docker container. So it's running as a Docker container. And the Docker container could serve as a standard STDIO port, which is what is required for MCP, or it could serve as an HTTP port as well. So the way the Docker container is built is it could run in either STDIO mode or HTTP mode. In this case, we are running as a HTTP mode here. So what I can do is I can say, show me the tables that are available in this SQLite backend. And it says I found 3 tables. Once again, you can insert, update, delete rows, all sorts of stuff you can play around with here. And I can also add this to Postman once it goes in the Postman collection. Let's look at here. So here is my SQLite MCP server, HTTP wrapper. I can say, show me the tools that are available that are hosted by this SQLite server. It shows the list of tools. And I can say, show me the list of tables. So it shows me the list of tables. Exact same response, because the Postman collection and the backend, sorry, the web app, they're both looking at the same backend. And that's the beauty of Postman, because you don't need to run the full-blown app. It is all encapsulated in a nice JSON file that you can give to anybody, set up your environments, like the GitHub token we may have to set, the OpenAI key we may have to set, Anthropic key we may have to set, depending upon what that needs to be done. Let's go to the final part of the app now. I'm going to do final part, which is the A/B testing here. And the way this A/B testing is going to work is I have some quick combos. And by combos, what I mean is, for example, I may want to select GPT-5 Nano and Llama 3.2 3B. I just want to do a quick test among them. Or I may want to say, I have a host of models that can be provisioned here using Llama. I have Llama 3.2 running right now. And then what I've done is I've said, instead of GPT-5 Nano, let's say I pick GPT-5 Mini here, okay? So, and I can pick a Claude model as well. So we're gonna let go of that for now. So, and then what I'm gonna do is I'm gonna say, run an easy test. So I say, give it a Python function and run this test. 2 models are selected. So now, exact same prompt is given to the 2 models, and it's going to return the response back to me. It's going to provide the response, and along with the response, you're going to see some analytics. Right, let's look at the results first. So this is explanation by GPT-5 Mini about what that simple Python function was. And then similarly by Llama 3.2 3B running locally, hosted by Ollama here. Now let's look at analytics here. Okay. Now if I look at analytics, it gives you total number of requests, average latency, cost, success rate. It does some verification checks, how it gets that verification number. And then there are a little bit more comprehensive charts that are available over here, which you can tweak to your usage here. Okay. Now, we're going to get a separate session on A/B testing on what these numbers should look like. But for now, let's add this A/B testing to our Postman once again. Voila. So I'm back to my Postman here. So let's run this collection here. And I'm going to say, take this A/B test, compare the 2 models, run the request. All right, we got the same result back here. Again, OpenAI GPT-5 Mini, and then Ollama 3.2, some initial response here. But then I can start saying, give me some A/B test results. So it'll start giving me some more detail. Pretty much the same way we were getting that data in the web app, we're getting that in Postman as well. So the beauty of this is, you can do all of your experimentation, different A/B testing in web app, and keep adding them to the Postman collection. And then you can hand over that JSON file to somebody with the right environment. They will be able to replicate it. Very cool. Okay. So now, where is all this work sitting? Well, that's sitting in my GitHub repo called as Postman-Labs. I've been working on this for a little while, so I think it's looking pretty good so far. It's got a comprehensive README. It talks about that we do A/B testing, multi-provider LLM comparison, GraphRAG lab, how we have different protocols that we are comparing. All the protocols are listed. Very nice developer experience. You literally have to clone the repo, fork the repo, whatever you want. Just fire up quick start. It should just fire it up for you, everything. Deep Postman integration. I'm planning to add some fun stuff to it. More like vector database APIs that could again be going back into Postman. Similarly, agentic systems. So I really want to give a shout out to ArangoDB. The integration was very straightforward. Really loved it. So yeah, give it a shot. See how it goes. I'm looking forward to your contributions here. This should really give you a platform by which you can do GraphRAG development with different protocols if you want to play around with them. LLM A/B testing and analytics and MCP server integration, all accessible through a web interface and Postman integration. Happy forking, submit issues, pull requests, whatever you like. Thank you.